Alright, so this is 3.1 part 2. So today we're going to start off with the natural base e. E is just kind of a value, kind of like pi, where pi is 3.14 and then it keeps going. E is this 2.718 that just, this decimal that keeps going. So e is just some type of number that we use in math. If we have e raised to the x, that is called the natural exponent function. This is where e comes from. It's this little formula here. As n approaches infinity, e just gets more and more decimal places. This is really not important. You can ignore this slide. If you care about where e comes from, this is for you. If you don't care, it doesn't matter. So let's look at our examples. So use a calculator to evaluate the function f of x is equal to ex at each value of x round 3 decimal places. So we just put this 4.2 into x, so we have e raised to the power of 4.2. You would put this in our calculator, so you would notice in your calculator that you have an e button. Anybody want to put this in their calculator and solve it? I got 66.686. Anybody agree with me?
Yeah.
Okay. So if you were using the phone calculator, you would put 4.2 and then you click that e raised to the x button. So just if you were using an iPhone calculator, this is how you would do it. I think in like a regular calculator, you would put like e and then the little caret 4.2. Okay, so for b, here we have 125 times e raised to the 0.05 times x. So we have to be careful with our order of operations here. We're going to plug 30 into x. So we have 125 times e raised to the 0.05 times 30. What operation do we have to do first here? We have to multiply the 30 times the 0.05. So this would be 125 e raised to the 1.5. And then we would do e raised to the 1.5, which is 125 times 4.481689. It's best if you just leave it in the calculator and then multiply it by the 125 so you get a more exact answer. So we get 560.211. Anybody agree with me? Anybody else got that?
Yeah.
Okay, good. So this is just putting it into the calculator. Alright, example 8 says use a graphing utility to construct a table of values for the function, then sketch the graph of the function. We're going to plug in numbers and see what our graph looks like. So what should we plug in? What should we plug in? Sure, let's plug in 1. So we have 4 times e raised to the power of 3. So e raised to the power of 3 is 20.08 and then times 4. It's 80.3. So that would be super duper high up here. What else can we plug in?
0.
0. So we have 4 times e raised to the power of 2. E squared is 7.3 times 4 is 29. .5. So this again is super high up here. What else can we plug in?
-2.
-2. So we have 4 raised to times e to the power of 0. What's e to the power of 0? 1. Anything raised to the power of 0 is 1. And then 1 times 4 is 4. So this is actually on our graph here. So you see our numbers keep getting smaller and smaller. What else can we plug in?
-1.
-1 again would be super high up here off of our graph. So let's plug in -3 because we want smaller numbers to see where our graph is going to approach.
Okay.
So we have 4 times e raised to the -1. E raised to the power of -1 is 0.36, and then this times 4 is 1.4. So about there. And then let's plug in -4 too. So we have 4 times e raised to the power of -2. Which is 0.54. About right there. So we see all of our values just keep getting closer and closer to the x-axis, but they're never going to touch the x-axis. When plugging in numbers, for an example like this or for what we did yesterday, we always want to look at what's happening to our x directly, and we want this to be 0 because we know that's going to be like our parent graph. So what I always do is I set what's happening to the x, so this x plus 2 equal to 0. We would subtract 2 on both sides, so x is equal to -2. This is the number that I'm going to plug in first. And then I want to plug in one above and one below just to see what my graph is going to do. So this is just a little helpful hint to see what to plug in. I mean, we can plug in 1, 0, -2, -3, -4. We can plug in as many numbers as we want. But it always helps just to see what exactly is happening to the x, set that equal to 0, and then this was the first number that you plug in. Any questions here? All right. Next we have compound interest and continuous compound interest. So this is something you probably have seen in Algebra 2. It says after 2 years, the balance A in an account with principal P and the annual interest rate R in decimal form is given by the following formulas. So if we have compounding interest, we would use this formula. If it's continuously compounded, we would use this formula. And then T is years. A is the balance in the account. P is the starting amount. So principal is just the starting amount. And interest rate is R. But it's in decimal form, so if we had 50%, R would be 0.5. So your rate always has to be in decimal form. So again, problems like this, we're just plugging it into the formula and then putting it into our calculator. Alright, so let's look at example 9. So find the accumulated value of an investment of $15,000 for 2 years at an interest rate of 3.2% if the money is compounded semi-annually. Okay, first let's name our P, our T, and our R. So what's our P? Our P is 15. It's what we started with, 15,000. What's our T? Two years. So our T is 2. And then what's our R?
3.2.
So 3.2 is the percent, but we have to change our percent into a decimal, so we would move our decimal place 2 times. So it would be 0.032. So you always have to change your percent to the decimal. Because for percents you have to divide by 100 to move it to a decimal. So that's why you move it twice. Alright, so if we have something that is compounded semi-annually, which equation do you think we're going to use? The first one or the second one from the last slide? The first one. We only use the second one when it's compounded continuously. So for A, B, and C, we're using our first formula, which is A is equal to P times 1 plus R over N times N raised to the power of N times T. How many times a year is semi-annually? Twice.
2.
Yeah, so 2 times a year. So our N is going to be 2. So we have A is equal to, now we just plug in, so 15,000 times 1 plus our R is 0.032 over 2 times 2 raised to the power of 2 times 2. Now it's important here that we just follow the order of operation, so we have to do everything inside of our parentheses first. So we're going to divide this 0.032 by 2. So this is 1 plus 0.016, so it would be 1.016 raised to the power of 4. Which is point. I think I did something wrong. Okay, so it would be 1.0655. It's always best to leave what you're doing in your calculator because then you're going to get a more precise answer. If we were to write this and only take 3 decimal places, it's going to skew our answer a little bit. So it's just best to keep it in your calculator as much as possible. So I got 15,983.2 .29. I got 0.286, but it rounds up to 0.29. Anybody else get this? Perfect. All right, so let's look at B. Any questions on that one? All right, B, we're doing the same thing. How many times a year is quarterly?
4.
4. So now our formula is the same, but for n, we're plugging in 4 instead of 2. So A is equal to 15,000 times 1 plus 0.032 over 4 raised to the power of 4 times 2. So everything else stayed the same. I'm just plugging in these for P, T, and R, and then I'm plugging in 4 for N. And now we solve. So what's the first thing I have to put into my calculator?
.032 divided by 4.
Perfect. 0.032 divided by 4. So here I get 1.008. And then, yeah. So I got 0.008 and then I added 1 to it. And now I'm going to take 1.008 and raise it to the power of 8. So I have 15,000 times 1.0658. But I'm going to keep this number in my calculator so it's more precise. So then times 15,000, which I get 15,987.31. Anybody else get this?
Yep.
Perfect. All right, so now we have compounded monthly. Well, what would N be for monthly? 12. There's 12 months in a year. So now we plug in 12 for N. So we have A is equal to 15,000 times 1 plus 0.032 over 12 raised to the power of 12 times 2. So the first thing we have to do is 0.032 divided by 12 plus 1. So this becomes 1.0026, repeating, and then raised to the power of 24. Sorry guys, I'm doing it in my calculator too, and I keep messing up. Okay, so here I get 1.066 times 15,000 so we get 15,990.02. Anybody else get this? Anybody at home get this?
Yep.
Perfect. All right, so now for part D. What formula are we using for D?
A r times t.
Perfect. So we plug in the same p, the same r, and the same t. So our p is 15,000 times e raised to the power of, what's our r? 0.032 times t, which is 2. So what's the first thing we have to do here?
Multiply the exponents.
Multiply the exponents. So we have 0.032 times 2. So this is 15,000 times e raised to the power of 0.064. Now what do I do?
You e to the power of 0.064.
Awesome. So we have to do our exponent. So e to the power of 0.064. And then we get 1.06609. And then we multiply this times 15,000. So I got 15,991.39. Anybody else get that? Super.